So why monitoring? I was really intrigued to come in. I was slightly late for Toby's presentation, but about the first 5 slides I've got, he's already done in a subtly different way. So you'll excuse me if I'm teaching you all to suck eggs here, but I do want to make sure that before we launch into ELK and Consul and all the rest of it, we're all talking from the same page. Because of my background, I tend to approach this from an operations point of view, but I've also got experience of working with small consultancies and larger organisations. So I approach it from a business point of view as well. So it's not just about, as Toby said, it's not just about whether the servers are online or offline. It's about what the experiences are that your customers see. So why do we monitor stuff? Well, for us, it's about responding in real time. People want immediate feedback. And it's not enough to know what went wrong yesterday. You need to know what your systems are doing now at this instant. And the stuff that Toby was showing about Sensu, it only holds the last 20 events. Well, 9 times out of 10, you probably only care about the last 20 events. That's really, really cool. And a lot of the reason why people only know about what went wrong yesterday is because of the technical debt. And one of the best stories that we've got about technical debt, so they've got these monitoring systems and these logging systems that don't give them the real-time view of their systems. And anyone here remember Blockbuster Video? Yeah? Okay. Why did they go out of business? It wasn't because they didn't see Netflix coming. They saw Netflix coming, and LoveFilm, and all the rest of them. But they had so much technical debt, they couldn't actually pivot their organisation fast enough. They didn't have the information they needed to make the decisions that had to be taken in order to get to a point where they could actually respond to what was happening in the market. Now, I don't know if there's any branches left in Bristol. I know that there's one slightly sorry-looking branch on the outskirts of Newport. But other than that, I've not really heard much from Blockbuster for a while. But the other thing about needing immediate feedback is what happens when your website gets listed on Slashdot or the register. People talk about the Slashdot effect. I've run web hosting clusters where things have been listed on the register or Slashdot, and all of a sudden you've got 10 gigabyte a second of traffic hitting your website, whereas previously it was only about 500 meg. How do you deal with that? Now, thankfully, these days, if we're using AWS or Azure or whatever, we can put in auto-scaling, we can take account of that. But it is a lot of the monitoring is about responding in real time. This is where we get into more of the business stuff. It is the check in PDCA. Anyone here familiar with the Deming cycle? Plan, do, check, act. It's something that comes out a lot in agile development. You wouldn't release code to production without testing it, right? Some people aren't agreeing with me. This is quite concerning. So why do your server configurations go out to production, regardless of whether it's Puppet, Chef, Ansible, or whatever, without being tested? Well, actually, if you run up virtual machines, and you can do this from Jenkins, and there's plenty of tutorials out there on how to do this, to launch virtual copies of your infrastructure, and then run your monitoring checks against that virtual test, you know that the systems, when you deploy them to production, are going to work exactly the same as they did when you ran the automated tests against them. And then you can take that one step further, and you can start to use your monitoring checks as test-driven development for your infrastructure. So you write your Nagios plugins, your Sensu handlers, whatever it is, and I would suggest, if you do go down this route, looking seriously at Nagios, the architecture of the monitoring solution itself is pretty horrible. The simplicity of the checks is beautiful. You kick out a line of text and you exit with either a 0, everything's fine, a 1, you should probably look at this, a 2, this is an error, or 3, I don't know what's going on. Jenkins, TeamCity, Bamboo, all these other CI tools, they treat anything other than a 0 as a fail. So even if you get a warning, if you're using monitoring to test your virtual infrastructure, your CI tooling is going to kick out at you and say, build failed, there's something wrong with your configuration here. And then you can start writing your monitoring checks first and then making sure that your configuration matches your monitoring. And then you ship the whole lot into production, including your checks, and it's all good. So it also tells the future. And this is where Logstash and Kibana come into it. And this is what Toby was saying about feeding the events out of Sensu, because in order to get a really good idea of what your platform's done and therefore how it's probably going to react at a later date, you need something that's going to give you not just the last 20 events, but the last hour, the last week, the last year of data. So that you can say, okay, well actually every time we push a deployment to that server, we see the CPU spike. Every time marketing decide to run a promotion on our website, we see the number of 500 errors in our code go through the roof. You know, where is it that that's coming from? How do we track that down? Okay. So if you can see where the errors are now, if you can see how your platform's performing now, and you've got a good idea of what the load is, then you'll be able to look at how you plan capacity around promotional events. And this is what I mean about looking at it from a business point of view. So Etsy have this wonderful thing. They have a wonderful blog called Coders Craft, or Crafters Code. I always get that the wrong way around. But they wrote a fantastic blog post when they first released Graphite that had this quote here. If it moves, we track it. Sometimes we'll draw a graph of something that isn't moving yet, just in case it decides to make a run for it. This is a really, really good principle when it comes to monitoring. Okay? If you think you ever, at any point, might want to know what that particular bit of code or platform is doing, create a metric from it. Creating metrics these days is so cheap with stuff like StatsD. You know, you can just pepper your code with decorators these days, and it'll automatically fire out to StatsD. StatsD will shove it into Graphite or Dataloop, which is a monitoring as a SaaS thing that we use, as a service thing that we use, or you know, InfluxDB or whatever. And all of a sudden, you've got a metric of how long those calls took in that code, in that function, or whatever. So something we're moving towards is this concept of a monitoring triangle. And this is about how all your different monitoring tools layer up. The idea is that at the top you've got your visualization platform. Now that could be the Sensu dashboards, it could be Kibana, it could be Grafana, it could be AppDynamics. Okay, it doesn't really matter. But you've got some way of seeing what's going on inside your application and your platform stack. And the way we work with this within DevOpsGuys is we then start with the customer. So what's the customer experience of your application, of your website or whatever? And for those we use analytics, so Google Web Analytics, Adobe Site Catalyst, that kind of thing. Real user monitoring, so something like New Relic, or if you're absolutely minted, AppDynamics. Then we start to look at the code. So synthetic transaction monitoring, application performance monitoring, log analysis, and this is where things like Kibana and the ELK stacks start to creep in. And then from there, once you've done your customers and what their experience is and what your code's doing, you move down to your core platform. What are your services doing? Is Nginx running? Is PHP FPM working? You know, is Apache and Mod Passenger, for anyone that hasn't done Ruby for 5 years, is still running? You know, what's your CPU doing? What's your RAM like and all the rest of it? But underpinning all of this, you have this security layer where you provide this, you have this framework for providing auditors with the log files that they want. No one likes, least of all sysadmins like myself, sitting there at the command line with 4 gigs of logs from multiple servers, trying to write some horrific bash or, God forbid, Perl script to clobber everything relevant together to hand over to an auditor. Okay? Build it into your monitoring system. If you can just hit a button that delivers a PDF that you just email to, you know, KPMG or whoever it is that's doing the audit, or your PCI guys or whoever, there you go. And it's got all the relevant information from the platform, your lives will be so much easier. And again, this is where the ELK stuff comes into it. We can provide compliance, you can look at governance, you can look at threat detection, and I'll come on to how we sort of achieve some of these. Just quickly, for those of you that aren't familiar with synthetic transactions and application performance monitoring, application performance monitoring is literally what's your application doing now. So it's a real-time view of all of the various call stacks that's going on inside your application. where are the bottlenecks. If you use something like App Dynamics, it'll actually bring you up a really nice picture of your entire infrastructure from an application-centric point of view, and say, well, at the moment, the latency between that call in your application and that database server over there is 4 seconds. So you click on it and it says, and it's because of this SQL query here, and you click on it and it says, because that table there isn't indexed, and then you send an email off to your DBA saying, please index that table, and hopefully everything goes away. New Relic will do similar kind of things, and is a very good place to start if you're not doing any of this kind of stuff with your code base. Again, very, very easy to, you deploy an agent, it hooks into your code base, it starts sending stuff back either to a SaaS offering or an on-premise offering, depending on how deep your pockets are, and it gives you a really good overview of what's happening. Synthetic transaction monitoring is more about how well are the less trodden paths in your site or application doing. So you're actually generating traffic for the bits of your website. So say you've got an e-commerce site, and your basket, your shopping basket process is, people are checking out 50 times a minute because you've got that many customers. That path through your application to add stuff into the check basket and all the rest of it will be picked up by your real user monitoring. You know what that's doing, you know what the response times are. Synthetic transactions monitoring is things like, okay, well, if someone goes to the contact form and asks us a question we only get asked 10% of the time, how do we know that that's still working? So you can generate all of these paths through your sites and things like that. But more than anything else, what we go for is taking this customer-centric approach to monitoring. And Toby touched on this again. It's not about are your servers and your services online. It's about what is your customer's experience. Because at the end of the day, they're the people that are paying the money that pays the bills, right? It doesn't really matter whether Nginx is online or offline if customers aren't visiting the website and they're not spending money, or they're not using your app, or whatever. So start with the users, move down the stack to the application, then onto the servers and the infrastructure. But provide stability at the base through security monitoring, log analysis, auditing, compliance, and all those other boring words that people try and run a mile from, but actually, having worked at both multinationals and startups, having done PCI compliance, having done FISMA, SOX, HIPAA, and various other things, are actually really quite important. Right, so this is the bulk of the talk. What are we going to talk about? I will get through this in the next half an hour, and I will even attempt to see whether my scripts have worked and we actually have an ELK cluster managed using Consul running in AWS. We will see. I know the Terraform bit works, it's the Ansible bit that's the interesting part. So, what is an ELK cluster? ELK is a really handy acronym, but it's actually in the wrong order. The E is Elasticsearch. This is our storage engine. Everyone familiar with Elasticsearch? Are people using it in production? Yeah? Awesome, good stuff. So I'll go into these a bit more in depth shortly. Logstash is effectively a black hole into which you can throw stuff and then manipulate it, and then it will end up somewhere else. It's basically an aggregation tool. It's very, very handy. It's written in JRuby, so it runs inside the JVM, which is interesting, especially getting metrics out of Logstash itself. You have to do some interesting stuff with the JVM, but I'm not going to go into that here. And then Kibana is the visualization thing, the visualization tool. Kibana is actually a visualization tool for Elasticsearch. So even if you're not using Logstash, anything that you're throwing into Elasticsearch can be easily turned into dashboards using Kibana. Okay, so that's, if nothing else, if you're using Elasticsearch and you're not using Kibana to query your data, at least take a look at it. It's a really good way of looking at unstructured document-based data. Consul is the bit that's going to glue all of this together. It effectively gives us DNS-based service discovery. And again, I'll show you what that looks like in a minute. But more than that, why am I using these tools? And we are using these tools at some well-known household brands over others. Well, the setup I'm about to show you is provides a really easy way to deploy and configure both the application and the systems. It gives you an overview of service health. It's redundant, and it's scalable, primarily thanks to Elasticsearch and Consul. So it gives you the ability to build up this platform that gives you an insight into what's going on in your system. How does it all fit together? Well, there's something called Terraform. Anyone know Terraform? Okay, so Terraform allows you, and I'll show you an example of this in a minute, but Terraform basically allows you to describe what you want your environment to look like. It then runs against Azure, DigitalOcean, AWS, Rackspace, OpenStack, DNS Simple, huge number of things, and configures things to be as you've asked them to be. Okay? So in what I'm about to show you, we get Terraform to talk to AWS. We then get Ansible, which is our configuration management tool of choice. Everyone aware of Ansible at all? At least heard of it? Yeah, cool. So it's like Puppet or Chef, except it only uses SSH. There's no need for agents on any of your boxes, or it uses the remote, not RDP, the remote shell, PowerShell stuff in Windows. In fact, if you're using Windows, the newer versions of Ansible will actually support PowerShell DSC for desired state configuration. That's something that we're doing a lot of work on for some of our customers at the moment. We get Ansible to talk to AWS and say which servers are available, what should I be acting on, and from that it then builds out a Consul server. Like I say, I'll go into Consul in depth a bit more in a minute. It then builds out an Elasticsearch cluster and some Logstash nodes and a Kibana dashboard, and then it tells them all to register themselves with Consul, and at that point it restarts all of the services and everything works. We hope. So let's go into these a bit more detail. Terraform is written by HashiCorp, who are the guys behind Vagrant and just about every other tool that is worth using at the moment. If you haven't checked out HashiCorp's website and their products, I really do recommend you do. We are not affiliated with them in any way yet. I would really like to be. They do some amazing stuff. It's written in Go, Go the language, as opposed to Go the CI tool that ThoughtWorks released as Go CD and then renamed to Go, just to make things nice and simple for us all. It does one thing and does it well, and this is a big thing of mine. I'm a big subscriber to this philosophy of do one thing and do it well. Terraform is fantastic at building out your infrastructure. It's really not that great at provisioning it and configuring it and all the rest of it. It'll build out all of your boxes for you, configure your load balancers and all the rest of it. The script I'm running this evening will do 34 objects inside AWS in under 2 minutes. So that's servers, load balancers, security groups, subnets, virtual private clouds, security group rules, the whole lot. Under 2 minutes, 34 objects. It's fantastic. It's stateful as well. So it looks at your environment, compares it to the state file it's got on disk and says, yes, that's how it should look, or no, it's not, I need to do this, I need to tear that down, rebuild that. And this is how you define an instance in AWS. You give it a resource type, AWS instance, you give it a name. We want 3 of them. Look up in a variable the AMI ID. Are people familiar with AWS here? If I start talking about AMIs and stuff like that. So AMI is basically Amazon Machine Image ID. And they're unique to each region. So what size do you want it to be? Which subnet do you want it to be on? Which security groups do you want it to be a part of? Which SSH key do you want it to use? Do you want it to be tagged with anything inside the inside the AWS console? These Ansible Group Elasticsearch servers and Ansible Group console clients, they're tags in AWS, but we use those in Ansible to work out which roles need to be applied to which servers. So we query the API, get all the group names back and say, okay, well, it's a console client, so it needs to have Go, it needs to have that, it needs to have that, it needs to have that. Okay? So that's just our way of grouping it. But from that, assuming all these other variables are set, it will just build 3 VMs. If I change the count, it will build 5 or 10 or 20 or however many I need. And you could quite easily set that count to a variable itself and have some sort of monitoring tool say, I'm noticing a huge burst of traffic in, we should actually have, that variable should be set to 20, run Terraform please. And Terraform will spawn out another 18 or whatever. Okay? Because it's stateful, it already knows that you've got 3 servers running. So if you say we should have 20 in total, it will only spawn 17 more. It will make sure that you have 20 in total running. Okay. So this is really useful. For anyone here using Azure for cloud stuff? Okay. You don't need to be embarrassed about it, sorry. Azure is actually rapidly becoming a very, very good cloud platform, I have to say. It's very, very capable in its things. They've just completely redone the API as well. So the Go library that Terraform uses to interact with Azure is not as mature as the one for AWS, so just keep an eye out for that. As AWS, pretty much any object that's out there that you can click on from the AWS console can probably be provisioned inside Terraform. There's very few that can't be, and that includes all your DNS and attaching your DNS to instances and all the rest of it. So, Ansible is Python-based. It uses YAML. This is our Elasticsearch role. We can do interesting things inside this YAML. It's not strictly YAML. Because you can have conditionals and loops and all sorts of other things that you probably wouldn't find generally in a text file. But we can do things like this. So if we're running Debian or Ubuntu, and Ansible knows which operating system family you're running, then include all the tasks that are appropriate for Debian, include all the ones that are appropriate for Red Hat-based systems, start the service, copy the configuration into place, notify that we need to restart Elasticsearch. So it'll do configuration management for you, it'll do orchestration across nodes. You can say, only run this task on that node over there, depend on that node over there, wait for this to happen, wait for that. And it's a really good, really simple tool to do for orchestration. It's also just been bought by Red Hat. And so expect to see it integrated with things like Spacewalk, Satellite, Cobbler, all of their kind of suite of tools fairly soon. Or at least in the next year or so. Goodbye by Red Hat, actually. Very, very sensible purchase. We love it. You don't need to install any agents on any of your servers. As long as your box is running SSH, Ansible can manage it, which is fantastic for us, especially in cloud-based environments. So, Consul. It's HashiCorp, again. It's Golang, again. It's DNS-based. It gives service discovery. It does have key value pair type stuff. Think more memcache than anything else, really. And it's got a full HTTP API through which you can configure it and do all sorts of other wonderful things with it. The service discovery part is brilliant. What happens is you have a DNS resolver, you have Consul client running on each of your nodes. You then have your Consul master cluster, and it uses Raft as the messaging protocol underneath, so it's really quite resilient. And you have a DNS resolver on all of your boxes that points to the Consul client installed locally on those boxes. And then when the services register, and I'll show you an example of this in a minute, when the services register, they register with something like elasticsearch.service.console. And then you configure Kibana to point to elasticsearch.service.console, and Consul takes care of that for you. It finds one of the nodes that says, yes, I'm Elasticsearch, and it redirects your Kibana queries to it. It's effectively internal round-robin DNS, but with health checks. If a service or a node goes down, Consul will stop serving that IP address as part of the DNS record to your client. So if you've got a large and very large sort of Elasticsearch cluster, where you've got a load of read nodes and a load of write nodes and archive nodes that are backed by EBS instead of provisioned IOPS or whatever, you can actually set it up so that you can say, okay, write.elasticsearch.service.console goes to the write nodes, read.elasticsearch.service.console goes to the read nodes. You can even break it down by data center so that your web servers in AWS US East 1 will always talk to the database server that's there, unless that database server dies, at which point they'll fail over to Rackspace New York, where you run the rest of your kit, because using just one cloud provider, you run into some interesting problems. Ask Netflix about that one. They've got a very, very good post-mortem on their website about what happened when Amazon lost an entire region. They now have code that runs around their production environment, switching off not just instances at random, but entire regions of instances at random in production to prove that their code is resilient. So this binds everything together. Elasticsearch, as I say, is Java based. It's HTTP. It's basically an HTTP API to the Apache Lucene library. So you get all of the power of those Lucene searches via HTTP. And you can see here, that's just a simple curl request, cluster health, and it's printed out exactly what's going on in the cluster. It will return documents. You can stick a query on the end of that, and it will go off and query your document store and all the rest of it. And they've written it in such a way that it's incredibly scalable. I know that NASA are running clusters that have got thousands of nodes in them and petabytes of data all sat in these Elasticsearch nodes. And it's incredibly flexible and very, very easy to query. We use it here because log files are not the best thing to shove into a relational database because they're just so varied in type. So when Jordan Sissel wrote Logstash, he thought, yeah, Elasticsearch, that looks like a good thing. Let's just throw it all in there. So finally, we get to Logstash. Like I say, it's JRuby. There are many ways to get data in and just as many ways to get the data out again. It allows filtering and manipulation. Scaling it can be a challenge, which is why we choose to use Consul. But it talks to Elasticsearch directly via HTTP. Now, to give you an example of the kind of things you can do with it, we've currently got customers where we are throwing not just Linux syslogs, but Windows event logs, application logs through .NET, NXLog and NLog, IIS application logs, we've got PHP application logs going into it. There are inputs for Logstash that allow you to connect to Twitter via OAuth and start slurping in tweet data based on hashtags or particular accounts and things like that. You can configure it to be a Graphite server. So if you want to fire all of your metrics into Elasticsearch, you can just do it through Logstash. Filtering the data, you can mutate the data that comes in. So you can add and remove fields. You can say, okay, well, it's great that IIS sends me the protocol and the FQDN and the full path and the file name and the query string and the response code and all the rest of it. But actually, I just want that as one field in Elasticsearch called HTTP URL. And these are all the fields that make up that URL, and it'll stick them all together, create a new field, stick it into Elasticsearch. It's automatically indexed. It's available to you in Kibana. So the mutate field is fantastic. It's got GeoIP built in as well. So if you've got an IP field, you can say, please work on that field as your geolocation information, and it will split it into a latitude and longitude down to city level if you go with the free version, if you're willing to pay for the MaxMind official database, which seems to be really quite expensive these days. I believe you can get down to street level. Which is really fun when you start mapping out where your HTTP attacks are coming from. I'll give you a clue, it's either Hong Kong or China. You can also output from Logstash to Graphite and to statsd. So as your log messages are coming in, your server 500 log messages, you're putting the log message itself into Elasticsearch so you can query it with Kibana, and you're sending a metric to statsd or Graphite that yet another 500 error or yet another 403 or whatever has come through the platform. So it comes back to this thing about do one thing and do it well. Kibana is very, very good at searching and displaying data sets for things like time series graphs and things like that. Definitely something like Influx or Graphite or one of those kind of things. So that's Logstash. And ultimately we view it all using Kibana. It's written in Node.js. It's an interesting story. It was part of Logstash originally, so it was in JRuby. And then it moved to a standalone Ruby on Rails application. Then it went to client-side JavaScript, and now it's Node.js running on the server. And that is literally revisions 1, 2, 3, and 4 in a nutshell. It now is a Node.js application. We stick Nginx in front of it because it's just nice to do that kind of thing. It talks directly to Elasticsearch over HTTP, it displays data, that's pretty much it. And because it's just a Node.js app, and because we're pointing it at elasticsearch.service.console, it scales really well because we just keep flinging out Kibana boxes that basically Nginx and this Node.js app configured to point to the right DNS place and stick them behind an ELB. And the Elastic Load Balancer just takes care of balancing all of the web traffic across it. So that's great. That works really nicely for us. So the configuration itself basically looks like this. So in your rsyslog config, send everything to the remote host logs.service.console on port 1514. That's it. Console worries about which of your Logstash nodes is actually up and running, which are listening on port 1514, where it should be sending the logs. You don't care, you just configure that on all of your boxes, you're done. It's going into Logstash, sorted. Logstash, oh, you point at elasticsearch.service.console, port 9200, which is where the HTTP API is, and Logstash just goes, oh, okay, fine. And console worries about whether Elasticsearch is up or down, and whether the cluster's in a degraded state or not, and which nodes it can send it to, and all the rest of it. This is why we love Consul. This is, and this is not the only tool that HashiCorp have done that brings this kind of level of ease to it. And again, Kibana, exactly the same thing. In the kibana.config, elasticsearch.service.console, port 9200. It goes off, it finds one of the Elasticsearch nodes, it talks to it, it runs the search against it, it presents the data back. It's that simple. So that's a brief overview of how we kind of configure all this stuff, and I realise I have shot through it. I'm kind of conscious of time, but the main points behind this is that because Consul itself is scalable, and because Consul works across multiple data centers, and because Elasticsearch, the storage backend, is scalable and works over WAN links and is scalable across data centers, actually all you really need, once you've got the DNS and the data storage in place, is 2 or 3 collectors, depending on the amount of traffic that you've got in each of your data centers, pointing at the correct DNS entry. And you can then have a Kibana cluster in one of your data centers that's querying everything. And scaling it out, well, all of these things support scalability, clustering. So you just throw another node into the cluster, be it Consul or Elasticsearch. And for Logstash and Kibana, you just provision another box and get it to register with Consul. By the way, I'm over here. Please start sending data to me. So it makes it really efficient to scale out infrastructure from, maybe 200 nodes, something like that are sending logs. Far fewer if you're sending all your application logs to it as well. Up to probably several thousand across various geographically disparate regions. So what does it look like? And have I sacrificed enough goats to the gods of demonstration? We shall find out. So that's a good thing. Everything's okay. Nothing in this column. Always nice. If I can find my mouse, it'd be even better. Here we go. So the script that's been running in the background, like I say, it provisioned these 34 objects, it's run Ansible, all the rest of it. The reason it's been running in the background is because it takes Ansible about 34 or so minutes to actually configure everything. So this is what Consul looks like. It gives you a nice web interface as well. Pocket is our data center. You can see all the services that we've got registered here. I can hit any of these, so graphite.service.console will point to a Graphite server, whatever. So that's what the web interface looks like. There's actually not much to it. The boxes on the end there go amber or red depending on whether stuff's failed or is working. The best bit about Consul is actually the underpinning DNS. So let's just have a look quickly at Kibana, for those of you who haven't seen it. Come on. This is where we find out whether it's worked or not. Here we go. Yeah, okay, so it hasn't. Well, it has. Logstash can only visualize data that's already there. This cluster hasn't been up and running and sending events long enough for the Logstash index to exist, therefore I can't index it. Which means I can't add it, which means we can't go through the searching and stuff like that, which is a shame. I was hoping that by now it would have generated enough data, but live demos and all the rest of it. I would recommend that you go away and look at Kibana. It allows you to, you can create a search, save that search, and then say, okay, I want to visualize that search. And you can turn that search into graphs of events over time. You can have one big number as a metric that you can display on your wallboard. You can have maps of the world with the geo-IP information all mapped on it and split out across, so you can see either where, like I say, where your customers are coming from or where the DDoS attacks that are going on are coming from. All that kind of stuff. If you're pushing more than just logging events into it, if you're pushing stuff from your web analytics or your monitoring tools or even your business process management tooling, this is the number of sales we've had today, this is the number of sales we had yesterday and all the rest of it. You can add more than one index to Kibana. So you can actually say, on a single graph, please show me the response time of the website, where all of my customers are coming from, whether sales are up or down based on this time yesterday or last year or whatever, and all that kind of stuff on a single dashboard. So it's a really good place if all your data is in Elasticsearch to have a good overview of what's going on without going down the route of paying for some kind of commercial offering that does exactly the same thing. I'm annoyed. The other things you do, pie charts, all that kind of, the usual kind of visualization stuff. But do go away and have a play with it. There is a blog post going to be going up in the next couple of weeks on our blog at DevOpsGuys about how you use this based on documentation we've recently written to hand over one of these clusters to one of our customers. And once that's up, I'll get the link around if people are interested. The final thing before we get cleared out and down the pub, I will say is, has anyone here heard of Splunk? Okay, so Splunk is an enterprise level monitoring tool. It does more than ELK will do. But ADP, who are one of the largest payroll processing organisations in the world, have just switched from Splunk to ELK because they believe that the direction that ELK is heading in is better for them as a business than the way that Splunk is heading. Now, Splunk is expensive, and cost did come into that decision. However, again, on the Elasticsearch website, all of these products, Elasticsearch, Logstash, and Kibana are now all owned by Elastic, the company. Elastic.co is their website. And on their website, underneath their press releases and all the rest of it, there's a good video about why ADP chose to drop this commercial offering that promises the world and, in fairness, delivers probably about 98% of what they promise. And migrated to this open source platform managed by, I believe it's managed by Elastic themselves. But this is what I'm getting at is that this isn't just, this is a tool that you can put into your organization at the beginning, and it will quite happily log, from the 5 servers that you've got in dev, test, and prod. But as your organization grows, because it's backed by Consul, because it's scalable through Elasticsearch, it can grow into multiple clusters. You can start doing interesting things with sharding, with historic data, with archiving, and all the rest of it, and it can actually grow with your organization until you do get, hopefully, because let's be honest, we'd all like to be there, to the point where you're someone like Amazon, where you're deploying to production 11 times a second, and everyone's throwing all of their logs at you, and you can just go, yeah, well, that's fine. This is what the graphs look like. That's a deviation from yesterday. My monitoring tools has told me what there is.